Bismillahirrahmanirrahim. So today lecture, I am going to teach you the two main content. First one is the packing of spheres in crystalline solids, and second will be the unit cells. So first, moving to the first objective of today lecture, that is the packing of spheres in solids, and particularly in the crystalline solids. So the idea behind the packing is because the metals uh, in a molecule, they assemble themselves to maximize the intermolecular forces of attractions. So they try to be close as much as possible. So there should be a minimum space between the atoms, and that is called the packing of the metals atoms in a solid. So here we are talking about the atoms in a similar way. The spheres are or the balls are going to be packed up. Like this is an example of selling of let's suppose the oranges. So if you have a look on these spheres or the oranges or the balls, so this is the one layer, and the second layer of these balls or the oranges are placed over the space between the two balls of the first layer. And in similar way, this packing is going to happen, and you will find in any of the cart or the man who is selling the oranges or the other fruits, or maybe you can put these ball at home, and of course it should be like this symmetry, because the second ball will be in between the space of the two balls of the first layer. So in this way you are going to minimize the space between the atoms, or in this way you are also going to maximize the intermolecular attraction. So this is our main objective, and there are different packing of the atoms or packing of the spheres in the crystalline solids. So there are actually four types, and we will be discussing over here. The first one is the simple cubic packing. And in simple cubic packing, like let's suppose this is the shape after the packing of the spheres in the cubic packing. And in this packing, let's suppose this is the first layer, this is the second layer, this is the third layer, and what is happening over here, uh, this is one ball, and other ball is placed just above uh, the ball of the first layer, and similarly the third ball is placed on uh, the uh, the surface of the second layer. So each sphere is touched by the six neighboring balls. How? Let's suppose this is, I am talking this is the central, or if you have a look at this ball, let's suppose this is going to be packed up with the fourth one and fifth one and sixth one, so on. If you look at this sphere or the ball or the atom, this ball is touched with the four neighboring, six neighboring atoms. And how? This is the one is the for it is own layer. That means if this atom, this is touched with this atom, this is one, this is second, this is third, and this is fourth. So this atom is touched with the four spheres at its surface, and one would be at above and one would be at below. So let's suppose this is the sphere. I'm talking with this sphere, and if you look at this sphere is touched with the one is here, one is here, one is here, one is here. So four are at one place or the one surface, and one would be at this side and would be at this front side. So four would be at the surface and one would be at above and one would be at below. So coordination number of each atom or the each sphere in this packing would be 6. So it is also written over here, each sphere is touched with the 6 neighbors for its own layer. And like if you consider this is the surface 1 2 3 4, and if this is the surface 1 2 3 4 for its own surface, and one is touched because each atom is touched one sphere above and one sphere below. So there are the six, each atom or the each sphere is touched with the six spheres. That's why the coordination number of each sphere in this packing is 6. Second is the body centered cubic packing, and the coordination number in this case is 8, and 4 above and 4 below. How? Now this is the actually the packing as I have shown before. In this case, if you have a look, one ball is placed in the space between the two balls of the first layer, and this is going to be happen in the same way. These are the two balls, and one ball is placed in between this space, and there is another second layer. So let's suppose this is the layer 1, this is the layer 1. Like in a similar way, these are the 3 6 9 balls are there. Of course there should be 9 balls at the first layer, and then in the second layer, each ball is placed in between the surface. So let's suppose if I put a ball over here, so this ball is touched with the four neighboring balls. So this would be at below, and similar way, if I place another layer over here, then it would be touch another four balls. So now look at this ball, this is the layer B. Layer B, it is placed in between the four balls, the surface between the four balls. So this is touched with the four atoms below, and this is also touched with the four atoms above. So that's why in this case the coordination number is 8, 4 neighboring above and 4 are below, and this type of packing is called the body centered cubic packing. Third one is the, this is called the hexagonal closest packing. And why it is called the hexagonal? Because it is looking like a hexagonal shape, and there are also two layers, layer A, layer B, layer C. This is layer A, this is layer B, this is layer C. So in this case the coordination number is 6. How it is going to be 6? Let's suppose this is the first layer, and look at this ball. This ball is touched with the 6 neighboring atoms or the balls. So the first layer, each atom is touched with the 6 spheres. So at this stage the coordination number is 6. Then this is the triangular depression. The triangular depression means this is the depression of this triangular shape. And now I am going to put over this ball. So this ball will be touched with the 3 spheres above, because this depression will fit on the this ball. So the coordination number in this case will be 3, because this ball is going to touch with the 3 spheres. And in a similar way, if I put a B layer over below, and this will be the same case below as it is happening at the above of this ball. So total coordination number would be 6. Total coordination number will be 12. 3 are in the same layer, 3 are above and 3 are below. So this type of packing is called the hexagonal closest packing. Fourth one is the cubic closest packing, and in this case the coordination number is also 12. Total coordination number is 12. And how this is the overview of this one shape. This is the top view of the hexagonal. So just look at these two shapes, and this is going to be, actually there is no change in the space, the or the, the space occupied by each ball in case of the hexagonal closest packing and cubic closest packing. I will share or clear more this concept in a next slide. So what is happening over here? Again, in a similar way, there are the three layers now: layer 1, layer B, layer C. This is layer 1, layer B, layer C. Similarly, this will be below this sphere, layer B and layer C. Similarly, this is moving up, or you may also add on this sphere, like this is layer A, layer B, uh, A, B, and C, and then again A, then again B, then again C. So this is A, B, C, A, and similarly this will be moving up. So how the coordination number in this case, in case of the closest cubic packing is 12. Again, this ball is touched with the six neighboring molecules. So in this case, six balls are in the same layer, and again this ball will be touched with the this one ball, that the depression between these three angles, and then the coordination number would be 3, and similarly the coordination number will be 3 above and 3 below, because the same repeating there will be the same repeating union of these triangle above this and below this. So that's why the coordination number will remain the same as in case of the hexagonal closest packing. So the coordination number in both of the packing would be 12. Now, what is the space used in each of the packing? The first we discussed the simple cubic packing, where the layer was AAA and the coordination number was 6. So 52% of the space is occupied by these spheres if the atoms or these spheres are packed with the simple cubic packing. And in case of the body center cubic packing, coordination number is 8, and the total space occupied in this type of the packing would be 68%. So rest will remain empty. So in these two packing, hexagonal closest packing and cubic closest packing, coordination number is 12, and same space is occupied by the spheres or the atoms when they have these type of the packings. So this is the packing of the spheres or the packing of the atoms in a crystal system. Now, moving to the second part, then I will take your questions over there. What are the unit cells? Because we are step by step moving towards the structural determination of the crystalline solids, and then we interpret the data. How can we use the XRD data to interpret or determine the crystal structure, or most importantly, its crystallite size? What would be the size of the particle or the crystal system uh, by using this XRD pattern? So unit cells, simply what are the unit cell? Again, unit cell is defined as the smallest repeating unit of the crystal structure. Let's suppose this is the crystal lattice or the crystal structure, and the smallest repeating unit would be called the unit cell. So in this case, this is the unit cell, and it is shown over here separately. This is the unit cell, and this is the crystal system. And when unit cell repeats itself, network is called the lattice. Actually, repeating of these unit cell again and again, it will form the crystal lattice. And smallest part of the crystal lattice is called the unit cell. Like here, if you construct a building, and these are the building blocks, each brick is called the unit cell, because this is the smallest repeating unit in construction of home or wall, whatever it is, the purpose. But the smallest repeating unit would remain the same. That is called the, this one is the unit cell. Now, let's suppose this is the two-dimensional structure, and yeah, if you if you want to identify the smallest repeating rectangular unit, so if your purpose is the to identify the rectangular unit, that is the unit cell, and then your strategy is to draw a perpendicular line over here, like these are shown over here, and then with the equal distance, let's suppose this is the central point, or this is the perpendicular line of this, perpendicular line of this, and you are going to join this line, and then going to join this line, just join all these four lines. It will be a rectangular unit, that is called the unit cell. And you can find many more unit cell over here. I'm taking over here. You can take another unit cell over here. You can take another unit cell. This is another unit cell. This is another unit cell. So these are the repeating unit, and these are the rectangular unit cells. So this is the way you can identify the unit cell within the crystal system or the crystal lattice. So in today's lecture, I am going to discuss the cubic unit cell, only the cubic unit cell. So there are three kinds of the cubic unit cell. The first one is called the primitive cubic. Second one is the body centered cubic, and third one would be the face centered cubic. So these are displayed over here, but I will discuss in the next slide to further explain what are the what is the difference between all these three kind of the cubic unit cell. And similarly, there are the other crystal system. They also have the their unit cell, but according to your content or the syllabus, we will be talking about just the cubic unit cells. So the first one is the primitive cubic unit cell. So in this case, this is the structure of the crystal skeleton of the simple cubic. You may also call simple cubic, or primitive is also same. The simple cubic or primitive cubic is the same thing. So metal in this case has atom at each of its eight corner. There are the eight corner, 1, 2, 3, 4, 5, 6, 7, 8. So there are eight corners in a cubic, where it is shared with the seven neighboring cubes, and that would come together at the same point. Let's suppose again there would be a cubic, uh, simple cubic over here, here, because there are the eight. So one, 1/8 uh, of each corner belongs to one given cubic unit. And because there are the eight corners, so and when there is the repeating unit on each side of the corner, then only as a result, only 1/8, yeah, eighth part of each corner atom belongs to a given cubic unit cell. So this would be when you have a crystal system. But here we are just talking about the primitive or the simple cubic unit cell, and the simple cubic unit cell where is there where only eight corners or the eight atoms in a system are present. So this is the shape, and this is the three-dimensional diagram of the simple cubic unit cell. Again, second is called the body center cubic unit cell. Uh, That means another example of the or another type of the cubic unit cell. It is called the body center. And the body center, if you understand the simple cubic unit cell, uh, just it is the a body center cubic cell has eight corners. Again, there are the eight corners because it is the cubic unit cell. So there should be the eight corners plus an additional atom in the center of the cube. That's why this is called the body center cubic unit cell. Cubic units are due to the eight corners and one atom of the sphere at the center of the cube. That's why this is called the body center, because this is at the center of the body, and that body is the cubic unit. That's why this is called the body center cubic unit cell. So this type of the actually the repeating unit found in the centered body centered cubic packing, as we have explained in the one of the previous slide. The third one is the face center cubic unit cell. Again, they because this is the cubic unit cell, and cubic unit cell is having the eight corners, four are there, and similar to the body center cubic unit cell, where there is only the one atom is present at the center of the body, and in this case, the face center is the plus an additional atom on each of its six faces are present, because there are the six faces, one, two, three, four, five, and six. That means four are around and one above, one below. So there are the six faces and eight corners. So eight corner, due to the eight corner, it is called the cubic unit cell. And in each face, there is an additional atom. So total additional atoms are six on each of the face. That's why this is called the face center cubic unit cell, because uh, one atom is present at each the central point of each face. That's why this is called the face center cubic unit cell. And this type of the packing in this type of the crystal system is the closest cubic closest packing. Again, this is the final overview and summary of the four kinds of the packing and the unit cell. This we have already discussed in the previous slide. Now important over here, these are the unit cell, and when there is the simple cubic packing having this type of the pattern, then the coordination number was 6. The space occupied by this type of the sphere is 52%, and the unit cell would be the primitive cubic or the simple cubic. Or you may say, when there is this primitive cubic or simple cubic unit cell, then the packing of stacking pattern or the packing of this pair would be the simple cubic. And when there is the body center cubic unit cell, then the structure or the packing of these spheres would be the body center cubic packing. Or in other way, you can say, if the packing of this sphere is the body center cubic packing with the stacking pattern of AB having the coordination number of 8, it would occupy 68% of the space. And then in this type of the packing, the coordination, the unit cell would be the body centered cubic unit cell. And this is the hexagonal closed packing. In this, actually it would be a non-cubic unit cell, because this would not be a cubic pattern. But in case of the cubic closest packing, where there is a repeating layers of the 3 ABC, then ABC, the coordination number is 12, the space occupied by in this type of the packing is 74, then the unit cell is the face center cubic unit cell. Or in other way, you can say when there is the face center cubic unit cell, the packing of the spheres or the atoms in a crystal system would be the cubic closest packing. So this is all about our today lecture.